What is the radius of the circle? They want me to find r. Well, I mean, I did this. 2 minutes, I said 120 seconds. If a plane's speed, oh, you know what? There is something that has speed and radius in it. I think it's centripetal speed is 2 pi r over the period. So I said, okay, I can get r by itself. R is going to be v times t divided by 2 pi. Stuff moves diagonally. Think that's right. So it's going to be, what's the speed? 170. What's the period? 120 divided by 2 pi. 170 times 120 divided by bracket 2 pi. And I got 3,250, which at first seemed a little large, and then I went, wait a minute, this is an airplane. 3,250, a little more than 3 kilometers. Yeah, an airplane doing a turn, I think the radius, and this plane's going pretty fast, and it's taking 2 whole minutes to complete the circle. Yeah, that seems about right. I was a little nervous at first, and I went, no, that seems good. So 3,250 meters. If you got that, 2 out of 2. Otherwise, I would give you a half mark if I saw the original equation, a half mark for getting the r by itself, a half mark for the numbers, and a half mark for the answer. What's the centripetal acceleration of the plane? Well, I got 2 options. I can find it using v squared over r, or I can find it using 4 pi squared r over t squared. I said no matter what, I'm using my answer from A. No matter what, I'm using r. So I went with the one that was the least amount of typing, because they gave me both v and t, so I could do both. So I said it's going to be 170 squared over, and I'm going to use my answer button rather than the 3,250. 170 squared divided by answer button, and I got 8.9. meters per second squared. So this plane is pulling just shy of 1 g. How big is 1 g exactly? 9.8. Okay. I would give you 1 mark if I saw that, half mark for the numbers, and a half mark for the answer. But if you got it right, 2 out of 2. Number 2 said, what centripetal force? Here, no free body diagram required. They're just asking me to find FC. That's like asking me to find F net. If they said find F net, I went straight to MA. If they asked me to find FC, I'm going to go straight to MAC. Which version? Oh, they gave me the period, so it's going to be m4 pi squared r over t squared. M is 12 times 4 pi squared times 6 all over 0.2 squared. I said, okay, 12 times 4 times pi squared times 6 divided by 12 squared. No, not 12 squared. That's a 0.2, Mr. Dewick. Read your own writing. 0.2 squared. And I got a really big force. Let me pause for a second. 71,100 if I go to 3 sig figs, newtons. And I got nervous at first. I mean, that's a big force. But then I went, wait a minute, Annika, what's the mass in this question? That's a bowling ball-ish. 6 meters, you and I are around 6 meters apart. So imagine a bowling ball on the end of a rope where you're at the end of the rope and I'm holding this end, okay? What's the period? That means it's rotating, I'm going to do some quick math in my head, 5 times a second. To spin a bowling ball around 5 times a second on the end of a rope 6 meters long, would that take a fair bit of force? Okay, I actually relaxed after I thought about it and I said, oh yeah, it should be a massive force. Mark, can you take home, please? I would give you 1 mark for that, half mark for that, half mark for the numbers. But if you got it right, 2 out of 2. Number 3, they just want me to find the centripetal acceleration. Okay, AC equals V squared over R. Really, the only tweak I had to do was I had to convert that to meters. Otherwise, it was going to be 5 squared over 0.25. Is this 100 even?
Yeah.
100 meters per second squared. About 10 Gs. 1 mark for that. Half mark for that. Half mark for the answer. Now we got to the meat and potatoes and free body diagram-y stuff. So you can expect a Ferris wheel somewhere in your future as well. Ferris wheel has a radius of 9 meters. It takes the wheel 25 seconds to go around once. If a person weighs 65 kilograms sitting on a bench, what's the force that the bench exerts at the top of the Ferris wheel? Okay. By the way, what's this question really asking me to find? Normal force. So in a Ferris wheel, your head is pointing up. This is a job for a free body diagram. What are the forces? I have gravity down. Normal force is pointing up. How do I know normal force is smaller? That's why I started to draw a short mg and I went, wait a minute, that's going to be a problem, and I erased it and made it bigger. Here, my equation is going to be mg minus normal force equals m8. Well, you know what? It's going to be 4 pi squared r over t squared. As far as I'm concerned then, there are 3 main variables in the Ferris wheel situation: normal force, radius, and period. Or if it was v squared over r, normal force, speed, and period. If I give you any 2, I expect you can handle finding the third one. I'm going to get the normal force by itself. I think I'm going to do the swappy dance. I'm going to get mg minus m 4 pi squared r over t squared. That equals the normal force. So if I plug in numbers, the normal force is going to be 65 times 9.8 minus 65 times 4 times pi squared times 9, all divided by 25 squared. I hope I get a positive answer. 65 times 9.8 minus 65 times 4 times pi squared times 9 divided by 25 squared. Is it 600? This person's normal would be 65 times 9.8. So they feel a little bit lighter. I tried to make this one fairly realistic. Ferris wheels, are they thrill rides or fairly tame rides? Tame. There's a little bit of a change, but it's not like you're getting a massive stomach feeling or anything like that. Typically, why are you going on the Ferris wheel? 2 reasons. Short line, nice view, right? What's the force at the bottom? So at the bottom, what are the forces acting on it? Get the obvious one. I have gravity down, I have normal force, and normal force is definitely winning because that's towards the center. So at the bottom, it's going to be normal force minus mg equals m4 pi squared r over t squared. I think I can just plus this over. I'm going to get normal force equals mg plus m4 pi squared r over t squared, or mg or m4 pi squared r plus mg. The order doesn't matter. Oh, I forgot to give you the mark breakdown, by the way. 3 marks. I would probably go something like this: 1 mark if I saw that, 1 mark if I saw that, half mark for the numbers, and a half mark for the answer. This is going to be m65 times 9.8 plus 65 times 4 pi squared times 9 all over 25 squared. And what I would actually probably would have done is if I had this sitting on my calculator, I would have just backspaced, changed it to a plus, and said, hey, how about 674? Is that right? Newtons. Otherwise, similar mark breakdown. 1 mark for that, 1 mark for that, half mark for the numbers, half mark for the answer. Yeah?
For physical question, will it always be just changing the subtraction?
No, not necessarily. Maybe for a normal force situation, maybe. Okay? But not necessarily for getting an R or a T or something like that. Yeah. Okay? And I don't know. I've never bothered trying to memorize a pattern because I'm going to derive it anyways. Too lazy to memorize a pattern. Ooh, roller coaster loops. Okay, they want me to find how fast. Well, this is a job for a free body diagram, although they gave me a picture, so let's see if I can label that. What are the forces? It looks like I have gravity down, and in this case, the normal force is pointing down. Who's winning? They both are. So my equation's going to look like this. mg plus normal force equals mv squared over r. And I knew to go with the v squared over r because they asked how fast. I don't know the normal force. Or what am I going to write for the normal force? I'm going to write the original mg drops down. 4.5 times your normal would be 4.5 mg. That equals mv squared over r. Will little kids and grown-ups both feel 4.5 times heavier? Yeah, why? Okay. Oh, even more basic. How many G's in this one? There's an invisible one in front. How many G's here? You know what 1 G plus 4.5 G's is? I don't usually do this, but why don't I gather like terms? I'll get 5.5 G's is V squared over R. That's kind of nice because I can get the V by itself pretty easy now. And am I going to get my old friend, the square root of GR with some other stuff? I think I am. I'm going to get V equals 5.5 GR square root. Kind of nice. V is going to be the square root of 5.5 times 9.8 times 11. (5.5) times 9.8 times 11 square root. You get 24.3. By the way, you're going to learn later today, none of you have ever been on a circular roller coaster loop. In fact, you would never build a circular roller coaster loop. It would not be a pleasant experience. We'll look at that in just about 10 minutes or so. It is cool applications today. After the first loop, the riders hit a second loop. At the top of the second loop, the rider is traveling at 16 meters per second and feel a normal force of twice their weight. What's the radius of the second loop? I think they're at the top, so I think it's the same. Oh, I forgot to do part marks, by the way. How was this worth? 4? So I'd probably go something like this. 1 mark if I saw that. I would probably go 1 mark if I saw that. I would probably go half mark if I saw that. I would give 1 mark if I saw that, because to me that's kind of the key. What are we at right now? That's 3, and I'd probably give you a half mark for the answer. I don't know, something like that. I'm going to argue in B. I think the free body diagram is the same. We have normal force and gravity pointing down. Okay, we want to get the R by itself. So it's going to be mg plus normal force equals mv squared over r, and this time they said the normal force is equal to 2 mg's. Again, little kids and grown-ups can ride this. That's good. I'm going to gather like terms again. I'm going to get 3g's equals v squared over r. And the reason I'm going to do that is it's much easier for me to get the r by itself. Stuff's going to move diagonally again. I'm going to get r equals v squared over 3g. It's going to be 16 squared over 3 times 9.8. 16 squared over 3 times 9.8. And I get 8.71 meters. What was the original one? 11 meters? So this loop is 8.71 meters. Four marks again. Okay, let me see. 1, 2, 3. I'd probably go something like this. 1 mark for that, 1 mark for that, 1 mark for getting the r by itself, half mark for the numbers, and a half mark for the answer. Can you give yourself a score, please, out of 23?